Hello, first graders. Happy Tuesday. It's me, Mr. B, and I'm here to guide us through our next lesson in the light process. Before we do, I just want to point out a couple of literal housekeeping issues. One is I am at home, and in the background you might hear some singing. It's my daughter, Sophia, who has her mother's beautiful voice, thankfully. And then I noticed that I actually have the camera pointed at the computer because we're going to watch a video on the computer from the Project Lead the Way website. And I noticed that you could see my image in the computer screen. So what's happening there is, first of all, you should see that I'm wearing a bandana to protect my unhairy head from the sunlight that's coming in through the window. You see the window behind me. So that's a good example of the light process where the light rays are coming in super fast. They are the light waves are reflecting off my head and off the window. Some of them are heading towards the computer screen, then they're reflecting off the computer screen, which is smooth and shiny, so it's almost a mirror image. And then some of them come into the camera, and then you see it on your computer or tablet, and the light rays go to your eyes and nerves and brain. So that's a pretty good illustration of science. All right, to get going for science today, we do need the packet that we started on last Friday, the Activity 3 packet. Last Friday we did page 1 together. So hopefully you've all done that. If you haven't, then pause this video and go back and look at last Friday's math lesson, print off the paper, do page 1 as you follow through the lesson from last Friday. For those of you that are ready to do page 2, we're going to start out, by folding our paper on the staple like this. And then if you look at the paper, subtitle says reflection. So I was just talking about reflection with the image of my bandana head on the computer. Now we're going to read and learn a little bit more about reflection from the Project Lead the Way video. Remember, this was the last part of the video last week where we talked about shadows. So when I click the forward button, we're going to go, first we're going to see a picture of an astronaut. It's an actual picture, and let's take a look at that and see if you can see the reflection in the astronaut.
Lightning is a source of light during severe
That's
storms.
not it.
Sound
Mr. B made a
light, which is why you see
mistake.
when you hear thunder.
Hold on.
If you hear thunder,
Sorry, I must have pressed the backward
we see
button.
objects
Okay, ready?
around
Here we
us
go.
because take a close look at this astronaut's helmet. This is an image of astronaut Buzz Aldrin as he walks on the surface of the moon. Can you see the astronaut who took the photograph? If you look closely at the helmet, you can see astronaut Neil Armstrong in the reflection.
So you see one of the astronauts was taking a picture of this astronaut, and I can't remember if it was Buzz Aldrin or Neil Armstrong, but they were the two astronauts, the first two to land and explore the moon. So you can see that this astronaut is, his image is reflecting off of the bigger astronaut that you see here. So what's happening is the light from the sun, the light waves are reflecting off of this astronaut. Then those light waves, the ones that reflect off of that astronaut, they go and they bounce off of the first astronaut's mask, and then they reflect back to the camera. So it's a pretty good example of reflection. Let's keep going.
Reflection is the return of light or sound waves from a surface. Any smooth or shiny surface can create a reflection. The lake in this image is reflecting the fireworks in the sky.
Okay, so when you look at this picture, water is excellent for reflecting light because it's smooth and shiny, just like the glass on the astronaut's shield or the glass on this computer is excellent for reflecting because it's smooth and shiny.
Now that you have learned about reflection, think about which of the following objects would make the best mirror: ice, sand, or a leaf. Write your answer in your launch log and explain your choice.
So on page 2 of your packet, it says, which would make the best mirror, ice, sand, or a leaf, and why? So to answer this question, we're going to have to write a complete sentence answer. So what you're doing is you're looking at the picture of the ice and the sand and the leaf, and you're thinking, which is the smoothest and the shiniest, the ice, the sand, or the leaf? So make your decision, and then on your paper, you're going to write, if you think it's ice, you're going to say ice, which is right here, I-C-E, because it is smooth and shiny, period. And if you don't know how to spell smooth and shiny, then do your best to spell it out. Make sure you have a capital at the beginning and mark at the end. If you think sand is going to make the best mirror because it's smooth and shiny, then you would write sand, S-A-N-D, because it is smooth and shiny. Similarly, if you think a leaf would make the best mirror, then you're going to write leaf because it is smooth and shiny. All right, after you finish that, I would say to press pause until you're done writing your sentence, and then when you're ready, you can press play as we continue.
Color is the way that objects appear different because of light reflected by the object. We see colors such as brown, red, yellow, and blue because of how the light bounces off of the object.
All right, so this is a pretty cool concept. When we see colors, it's because only that color of light wave reflects off the object. So depending on what an object is made out of, like for example, next to my computer I have some Clorox wipes, and on the Clorox wipes is a label that's got a lot of yellow on it. Well, the reason we see yellow is because the light waves, when they reflect off the paper that the label is written on, that paper has a type of paint that only reflects yellow light waves. So remember we learned last week that there are 7 main colors of light waves, right? Red, orange, yellow, blue, indigo, and violet. Red, orange, yellow, green, blue, and violet, and indigo. Let me say that one more time. I think I keep forgetting one. So red, orange, yellow, green, blue, indigo, and violet. There's the 7, okay? So this paper is made out of an object that only reflects one, yellow. So the light from the sun, the light wave bounces off, and only the yellow light wave reflects back to your eye. That's where color comes from. And it's all depends on what the object is made out of. The colors of objects depend on what color of light wave will reflect off that type of object. That's the big idea there.
Colors of light can be mixed together similar to how you mix paint. Unlike paint, when red, blue, and green light are mixed together, you see white light. Answer the questions about mixing colors of light in your launch log before you continue.
All right, so the big idea now is when you mix all the colors of light together, you get the color white. Okay, so for question D on your packet, it says, what color do you see when the colors of red, blue, and green are mixed together? So we just talked about it. What color do you see when you mix red, blue, and green together? On your packet, you're going to write your answer. You're going to write a complete sentence. It says, you see, and then write the color you see when you mix red, blue, and green. If you don't know, if you don't remember, go back, rewind the video a few seconds, maybe a minute, and watch again. Okay, so please press pause till you're done answering letter D, and then when you're ready to go on to E, the human eye, you can press play again.
The color white is made up of many different wavelengths of light. Light slows down just a little when it travels through something more dense. When light travels from air into water or glass, it slows down and looks bent. The colors that make up white light slow to different speeds, so the colors separate in a process called refraction. Refraction is the process that reveals a rainbow.
So the big idea on those parts of the video, those slides, is that just like when you combine red and blue and green and really all the colors of the rainbow or the spectrum, when you combine them you get white. Well, the opposite can happen where you can take white light, normal light that comes from a light bulb. If you shine it through a glass, it doesn't reflect, it refracts. It breaks it down into the different colors of the rainbow, the red, orange, yellow, green, blue, indigo, and violet. And that's what you see when you see a rainbow. What's happening is the light is going through the water of the rain, and the water of the rain is breaking up the light into the colors of the individual colors of light. We call them the rainbow colors: red, orange, yellow, green, blue, indigo, and violet. That's why we sometimes see rainbows after rainstorms.
Complete this sentence in your launch log. We see an object when light bounces off of it and enters our eye.
Okay, so follow those directions to fill in the blanks for E. We see an object when blank bounces off of it and enters our blank. Okay, good.
Congratulations! You have now completed the Exploring Light learning experience.
Okay, so in our packet it says, why do you not see objects in total darkness? So think about it. The beginning of the light process is when you have a light source, usually the sun, that sends light waves that reflect off of an object and go back into your eye. So why can you not see objects in total darkness? Meaning where there is no light source. So what you're going to do on your packet is write a complete sentence, and you're going to use the words from the question in your answer. So let's pick out the key words. The question is asking, why can you not see objects in total darkness? Who is this question about? You. So your first sentence, your naming part of your answer can be you. And then can not see objects in total darkness. That's the beginning of your sentence. You cannot see objects in total darkness because, you can sound that out if you don't remember how to spell it. And then finish the sentence. Why? Why, if it's totally dark, why can you not see objects? Don't say because it's dark. Tell me what it means to be dark. What's missing if it's totally dark? All right. When you get done with that, we're going to pause for today's lesson. Next time, we'll finish the packet where it says draw a picture below showing how we normally see things. And we're actually going to do that on the last page. We're going to draw a picture showing how we normally see things, but not for today. So go back, please, check your work, make sure you have capitals in the right place, end marks in the right place, finger spaces between your words, and that you did your best with sounding out your spelling. So if you don't know the spelling by heart, at least pick letters that make sense, that have the sounds that you hear in the words. All right, thanks a lot. Have a most excellent day.